Hello everyone, welcome to our first lesson today. So today we're looking at the conditions for life on Earth, and that's the first part of this. So today what we'll look at is the Earth before life, and then once we've done that, we're going to look at the features of Earth that made it suitable for life to become. So there's 5 of these that we need to know. There's the mass, there's the distance from the sun, axis of rotation, speed of rotation, and magnetic field. So to start with then, the Earth was formed 4.6 billion years ago. So BYA stands for billion years ago, in the remnants of an exploded star. And around the early sun, a cloud of dust was found. And these early clouds of dust sort of coalesced around areas of higher density to form early planets. And there was quite a lot to start with in the early solar system. It was really complex and chaotic, but they were drawn together by the force of gravity into tighter and tighter clumps. Now, the force of these particles colliding with each other slowly increased the size of the planet, but also made it hotter and hotter. So it was a molten ball of rock initially. All that heat from the collisions, the friction of the particles settling, and we still have that heat to this day in the core of our planet, sort of sealed away, sealed in there. Over time, the surface of this planet cooled as heat was emitted into space, and this is our crust, and that gives us our solid layer in which we live. So some of the features of this planet that made life possible includes the mass of the planet. So our planet is big enough that it retains an atmosphere. And the reason it retains an atmosphere is because it's the force of gravity generated by that mass is strong enough to keep those really light molecules and atoms of gas close to it. Okay, so we have an atmosphere retained by the force of gravity, and that gravity is generated by the mass of the Earth. And we can see other planets in our solar system where this hasn't happened. So Mars is actually quite a bit smaller than the Earth. So this is Mars. And because it's so much smaller, its force of gravity is much smaller as well. And in the past, there was an atmosphere, and there still is a very small, thin atmosphere, but the majority of it has been lost to space. And the reason having an atmosphere is so important is those particles, those gas particles in the atmosphere. So here's our atmospheric gas particles. They exert a pressure onto the surface of a planet. So we have an atmospheric pressure that is high enough, because there's enough gas, for there to be liquid water. So this liquid water in part is due to us having a high atmospheric pressure. Okay, and water is really important for life. It's a really important solvent. It helps prevent things from overheating, because it's got a really high heat capacity, and we'll learn a bit more about water in a future lesson. So next one then is the distance from the sun. So our sun is an enormous ball of radiance, and it emits all the time electromagnetic radiation. This electromagnetic radiation is all the different frequencies of wavelength of light. And if we are too close, so this is our electromagnetic radiation, and we call that solar insolation. Okay, if we were too close, so if we were within 100 million kilometers, it would be too hot. Okay, if we were beyond 250 million kilometers, it would be too cold. So it's too cold over there. But we find that the Earth is in an area of the solar system that we call the Goldilocks zone. And this is where it's just about warm enough for liquid water to exist. So here's the Earth. So it's not too hot or too cold for liquid water to be present at our surface. And this is a really important thing. Liquid water is really important for life to develop.